Hey guys, my name is Kaylin, and I work for the Papio-Missouri River NRD. Today, we are going to get our feet wet and learn about benthic macroinvertebrates. Let's take a step back. What is a benthic macroinvertebrate? Benthic means occurring at the bottom of water. Macro means you can see it with your naked eye without the aid of a magnifying glass or microscope. Lastly, invertebrate means that they lack a backbone. So if we put all three together, we have a small animal lacking a spine living on the bottom of streams, rivers, or lakes. All of the macroinvertebrates we are going to explore today spend at least part of their life in water. Most of these macros go through either complete metamorphosis or incomplete metamorphosis. You might be wondering, what does that mean? Metamorphosis is the process in which these macros grow into adulthood. Let's first look at complete metamorphosis. We will use a midge for our example. An adult midge lays a mass of eggs in an aquatic habitat. From the egg hatches larvae, in this case, a small, red worm-like figure. From there, the larva pupates, becoming what is called a pupa, similar to that of a butterfly. Lastly, from the pupa emerges the adult midge. Until this point, the midge's entire life is spent in the water. Incomplete metamorphosis has one less step than complete metamorphosis. To learn more about this life cycle, let's look at a dragonfly. Their life cycle begins as an egg laid in water also. However, after hatching from the egg, they are what's called a nymph. A nymph is the immature form of the adult. Over time, that nymph continues to grow larger and will molt its exoskeleton several times, eventually turning into an adult dragonfly. At the Papio-Missouri River NRD, water is a big part of our jobs. We place a high priority on keeping our rivers, lakes, and streams clean by minimizing harmful pollutants. But how do you know if a body of water is polluted? If it's clear, does that mean it's clean? Clear water does not indicate clean water. However, there are several ways to test bodies of water for pollutants. One way is by testing water for its chemical composition, using a water quality meter. This can help determine what pollutants are present. Another way of testing is by sampling for plant and animal diversity. For many agencies, the best approach is by sampling for macroinvertebrates. Benthic macroinvertebrates are great water quality indicators, as they have a limited ability to move habitats. They are found in large populations, are easy to collect, and have known tolerances to pollution. Some macros don't tolerate pollution, so if you find a high diversity of these macros in healthy numbers, that's a good sign. Here's a hint to remember when determining if a macro is pollution intolerant. If it ends in fly, it's usually a good indication of healthy water. Here are some examples of macros that don't tolerate pollution. Take a look at this dragonfly. Did you know dragonflies can fly at speeds up to 35 miles per hour? This green darner dragonfly pictured travels more than 900 miles from Canada and the US to Mexico. Here's a damselfly. Damselflies are often confused with dragonflies. Unlike dragonflies, their wings fold up together, and they are not nearly as strong of flyers. They are known to stay close to vegetation and water. In fact, their first year of life is spent in water, in the nymph phase of metamorphosis. This is a stonefly. Stoneflies get their name because they prefer to occupy stone and pebble crevices as a nymph. They're also close relatives of a not-so-popular insect, the cockroach. Yet another fly, the mayfly. Mayflies are best known for their giant hatches, numbering in the thousands, as well as their extremely short lifespan as adults, living for only a few days. Next up, the caddisfly. There are over 1,300 species of caddisflies in North America alone. As nymphs, caddisflies build protective cases around their soft bodies to protect them. These are made of pebbles, sand, and other materials. Here's a Dobson fly. Both the aquatic larva and adult fly can be surprisingly large. The larvae are also called hellgrammites and feed on numerous small fish and aquatic larvae. The adults' lives are rather short, living for only 3 to 10 days. Lastly, we have the cranefly. These craneflies might look like bloodthirsty, oversized mosquitoes, but they are actually a harmless, much gentler invertebrate. As aquatic larvae, craneflies look like a gray grub with a worm-like body. At this stage, they are commonly nicknamed leather jackets for their tough outer skin. There are really no bad macroinvertebrates, just species more tolerant of pollution. They're not litter bugs, they don't cause pollution, their presence or absence indicates the quality of a water source. Some macros can handle lower water quality. If you find a lot of these, and not many of the pollution-sensitive species, you might have a body of water with poor water quality. Let's take a look at some of the species that might be more tolerant of pollution. Check out this scud. These side swimmers are actually a small crustacean called scuds. They do not go through the same life cycle as an aquatic insect. Instead of having separate larval stages, small scuds grow into larger, mature scuds. This is a tubifex worm. These small, segmented, bright red worms are found in sediment at the bottom of lakes, rivers, and streams. They can survive with very low oxygen by breathing through their skin and waving their tail to utilize all available oxygen. Look at this leech. Leeches don't go through metamorphosis, so their body keeps the same appearance as it grows. Unlike leeches in other parts of the country, it is rare for them to attach to humans in Nebraska. They are much smaller than ribbon leeches, used for fish bait. These guys measure in at only a few inches. And finally, the midge. Similar looking and related to mosquitoes, midges are often called gnats. Most are non-biting, but can still be a nuisance when they swarm in large numbers during the summer months. Like our blood, the larvae, also called bloodworms, are bright red due to hemoglobin. Hemoglobin carries oxygen through our bloodstream and allows midges in this stage the ability to get oxygen even when levels are low. Let's sample for some macros at the beautiful Platte River State Park. One important piece of equipment is an aquatic dip net. This net has a very fine mesh on the bottom, which is helpful to filter out water, but collect samples of macroinvertebrates. You'll notice Mr. Austin takes the net and sweeps it across the bottom of the stream, gathering some of the sediment. The sediment, or mud, that makes up the bottom of the stream is usually where you'll find a variety of different benthic macroinvertebrates. After each scrape of the bottom, it's helpful to look into your net and check for macros. Let's give it a try. Don't forget, macroinvertebrates can be pretty small, so look closely. How many do you see? Check out some of the macros we found today. A midge larva, a scud, a leech, a dragonfly nymph, a damselfly nymph, and a diving beetle. To really test water quality, it would be important to sample many parts of the body of water and record our findings. We would also want to sample on multiple days and during different seasons. The more information we have recorded, the more accurate our results will be. Check out this water quality tool. This is called a Hester Dendy sampler. When studying water quality, surveyors will toss this out into a body of water, tie it off to the shoreline, and let it sit for a few days or weeks. The Hesterdendi is designed with multiple plates, giving a lot of overall surface area for benthic macroinvertebrates to collect. After surveyors retrieve the Hesterdendi, they are able to take each plate off and identify what types of macros are on it. Thanks for joining us today as we explored water quality and macroinvertebrates. For more information about the Papio-Missouri River NRD, you can find us on all the social media platforms or by checking out our website at www.papionrd.org.